Okay. Hello, everyone. I'm going to be doing what I did the other day, which is going through my notes on Emergence and discussing Emergence. I really should have moved this to the other screen. Let me just check quickly if that's possible. Yeah, whatever. Okay, so this is another paper. So, okay, maybe I should just reiterate slightly what I did yesterday, which is to discuss the difference between strong and weak emergence. Give evidence that it's possible to conceptualize something like strong emergence. Because so far it's pretty much universally accepted by people who know about emergence and how things emerge that weak emergence is real. It must be real. It must at minimum be real because clearly sophisticated systems exist, and I'm not just talking about living organisms, although that's a very clear example. But any kind of form of structure, any kind of form of molecular structure, is an example of weak emergence. So atoms giving rise to molecules, those molecules are weakly emergent. And then the question becomes, are there things that are strongly emergent? So a weakly emergent phenomenon is rather simply basically a novel kind of phenomenon that arises from smaller constituents and smaller fundamental laws, i.e. the fundamental laws which govern those smaller constituents. And it's totally consistent with those laws. So the phenomenon itself might be novel and not something you would necessarily expect given the fundamental laws, but you can check the fundamental laws and see how it's possible to give rise to this higher phenomenon. And the simplest way to check would be with a computer simulation. So you add all the components to your simulation, and then you stipulate that the matter in this simulation should interact with each other according to these rules. And if that phenomenon can occur in that simulation, given those simple rules, you know that it's weak emergence. But the question is, are there examples of strong emergence? And strong emergence is different from weak emergence in that it produces new properties. It produces new phenomena that are not predictable from those fundamental laws. Not even in principle. There's no way to get from those laws to this new phenomenon. It's a brand new thing which exists in the universe, and it was totally unforeseen if you just based your ability to foresee things on fundamental laws. But it's also kind of transcendent of those laws, and very importantly, it has a downward influence on those laws. So it's not just the laws that kind of create the conditions for this novel phenomenon to exist. It's also that this novel phenomenon is having an influence on those lower laws in the downward direction. Now, this is rather contrary to materialism, or at least the notion of free will put forth by materialists. Because in that notion, in that idea of free will or lack of free will, the idea is that everything you do is at a fundamental level just particles pushing particles. And even though you have a sense of agency, really at the fundamental level, it's just particle interactions, and you don't really have any control of it. It's just particles going where particles go. But the idea of strong emergence, assuming that free will and assuming that consciousness and sentience is a strongly emergent phenomenon, is kind of puts a hole in this idea of material causation, because it implies that free will might be something, or more specifically sentience might be something, which can actually subvert the fundamental laws which governs all fundamental particles. It can actually act apart from them. So you can no longer say that a person is merely just particles being pushed around. A person is this other entity, this strongly emergent entity, which is now able to influence matter. Not the other way around. Well, I mean, it's kind of like a bidirectional causation, where matter is influencing your body and your actions. Okay, that's true. But there's this other thing called consciousness, called sentience, which is having a downward influence on those particles. And this is rather obvious in my opinion because, like, take the example of you just moving your fingers, for example. Like, if I just did the math on your fingers to figure out what trajectory, what position, what momentums they would have, there's no way I could predict that they're gonna start moving if you start moving your fingers. Is because your mind, your psyche, is having a downward influence on matter, causing matter to act in ways that are actually, in a sense, contrary to the laws of matter. They're not breaking the laws of matter, but they're just doing something that you wouldn't expect. Because if you did this Lagrangian calculation for the matter in your hands, you would probably get that it stays still. But then there's this additional thing called mind, which is able to influence matter, which is not predictable from the laws of matter. Which is having an influence on the particles in your finger, causing them to move in a novel way. So really all we have to do is show that free will is a strongly emergent phenomenon to show that materialism is inconsistent, or materialism does not actually contradict, not materialism, sorry, determinism does not actually contradict free will. So determinism can be true, but then it can also be broken with respect to certain complex systems, such as a human psyche, and this will show that free will can exist despite the universe being deterministic. Now, last time what we did was we discussed a bunch of papers from Van Hatteren. We also discussed another paper which talked about proteins, showing how some enzymes are good candidates for being examples of strong emergence. Specifically from the concept of irreducibility. So irreducibility is the idea that in order for a phenomenon to be strongly emergent, it has to have all of the right ingredients. And if it's missing any of those, it won't have the new property. So in the case of proteins, this talked about a protein called pyruvate kinase, which is very common. In fact, I think I learned about this when I was in high school. And it's very well known and well understood. But basically, these scientists showed that if you're missing one fundamental component of this protein, and it's huge, this is a huge protein, so you wouldn't expect one fundamental component to make such a big difference, but that one component will suddenly cause this shift, which gives this protein a brand new property, which is strongly emergent. But they haven't proved that it's strongly emergent in the sense of being like a brand new property that's unpredictable from their fundamental laws. All they've proven is the irreducibility aspect. But I think that irreducibility aspect is just easier to prove, and then the other aspect is something that will be proven. So what I'm going to be doing in this stream is talking about this paper. We've talked about a bunch of papers from this author. He explained multiple mechanisms that can show strong emergence. So this is very key. It's not that strong emergence is a completely theoretical concept that exists entirely inside our minds, or entirely on paper, or entirely let's say not theoretically, but entirely not even conceptually, because it can be conceptualized. Maybe like as an imaginary idea, as like just like a theoretical idea that has no basis or mathematical backing. You can actually show that there are many systems that exist or that you can construct that are actually strongly emergent, that actually have strongly emergent principles, that are not predictable from the fundamental laws which govern the parts of whatever system you're working with. The creative way, and there are multiple ways to do this, but the way that this author did it was to create a system which combined randomness with determinism in a very special kind of loop. And you can see this loop down here, which is very characteristic. This isn't exactly the same thing that he constructed earlier in a subsequent paper, which we looked at previously. But it is similar, and it has that kind of loop-like dimension where you combine determinism and randomness in a loop. And what this pretty much shows is that there's no way to predict the system because it has that randomness, but the system also has agency and is able to, because it can reference itself, because it has the idea of itself within itself. So basically what that refers to is the fact that this organism, you imagine a hypothetical organism modeled by up here, this system S over here. You can't see my cursor, but my cursor is like right here. Imagine that organism has a system whereby it's able to represent itself and represent its own fitness with respect to an environment. So this system, this ability to represent itself, creates this new principle called the accuracy of its fitness. So it can estimate its own fitness, and this causes the organism to change its behavior whenever its fitness is low, or to keep doing the same behaviors when its fitness is high. And it's in within this construct. Um, One second, I'm just gonna have a drink of water. It's within this construct that um, that a strongly emergent principle or property can emerge, and that's C over here. So this C thing right here is actually a strongly emergent phenomenon, rather contrary to what we normally expect. Because it's, as you can see, it's kind of disconnected from the loop in that it doesn't emerge from the components of the loop, from the system, but it does come into existence as a result of the complex interaction between the components of the system. But let's not talk too much about that, since I discussed that last time, and I'm fairly familiar with it. So what I'll do instead, give me 1 second, I'm just gonna clear my nose. My nose is a little stuffy, making it hard to breathe, talk and breathe at the same time. Okay, so I'll be reading this paper, or the notes that I've taken on this paper. Some of these will be my own notes. Some of these will be things that I just copy and pasted from the paper, that I found interesting or helpful. I won't spend too much time on this paper because you can see there's a whole bunch of diagrams, and these diagrams only make sense because I made additional notes on paper that I have in front of me right now. You can hear the paper crinkling. And that kind of clarifies what the diagrams are about. But maybe I'll just speak about what he says, since much of it will probably be helpful. So he starts with, so this is the abstract. I'll just read this. Purpose and meaning are necessary concepts for understanding mind and culture, but appear to be absent from the physical world and are not part of the explanatory framework of the natural sciences. And they're right aware, in that sentence, you get a sense of what emergence means, because there are these things that don't seem to be part of the physical world. Like, you can't describe purpose in terms of atoms. Like, what atoms go together to comprise the idea of purpose or the idea of meaning? Like, it doesn't make sense as a question. So is this brand new thing that comes into existence as a result of more fundamental laws interacting in interesting ways? Understanding how meaning in the broad sense of the term could arise from a physical world has proven to be a tough problem. The basic scheme of Darwinian evolution produces adaptations that only represent apparent as-if goals and meaning. That's the kind of perspective you can take on evolution, where, like, you say, and it kind of makes sense actually, because you say that, like, an organism doesn't actually okay, so it might seem that an organism's goal is to survive and reproduce, right? Like, that's what's driving it. But in a more, like, from a different perspective, if you look at it and you think about it, the organism doesn't have any inherent goal. It's just that organisms that do this tend to survive and tend to continue to do it. So it's not as if the organism has a goal. It's just that evolution has caused the organism to be like this, and it doesn't really have an inherent goal. It's just kind of fulfilling what it was predisposed to do in accordance with its genetic heritage. Okay, so here I use evolutionary models to show that a slight evolvable extension of the basic scheme is sufficient to produce genuine goals. The extension, targeted modulation of mutation rate, is known to be generally present in biological cells and gives rise to two phenomena which are absent from the non-living world: intrinsic meaning and the ability to initiate goal-directed chains of active causation. What this is referring to is, like, agency, and the ability to control one's destiny by having a direct impact on one's behaviors. So it's literally just, like, if you just think about this existing within the simplest cells, This shows that like the simplest single-celled bacteria have a kind of form of agency if they're capable of representing themselves within themselves. Okay, so they have the idea of themselves. Now, they might not necessarily have that idea, but they might have something like analogous to that idea. Something distributed within the structure of the cell, which pretty much gives it a representation of itself relative to its environment. The key thing here is that it has a way to test its environment. Why is this? Anyways, yeah, it has a way to test whether its own fitness, its own internal concept, matches how it perceives things externally. And see if there's a match, then we're good. Like, I don't need to do anything. But if there isn't a match, it activates this chain. It basically just activates its rate of randomness, either randomness of mutations if it's a cell, or randomness of behavior if it's an organism that can't like evolve on the fly, so to speak. And that gives it a higher chance of survival because it's now able to do novel things in a situation where it's not well adapted to survival. But by doing these novel behaviors, it might increase its chance of survival by doing something that's conducive to its own survival. So, for example, like if it's some kind of animal that doesn't if it's some kind of animal that normally doesn't dig for its food, and then it finds itself in a situation where it matches its internal fitness to its external environment and finds a mismatch, i.e. it's not fit. So again, it has the ability to represent itself. And if it checks this self-representation and there's a mismatch between it and its environment, it will start doing novel behavior. So if it doesn't normally dig for food, maybe it starts digging for food. And that behavior itself is random, but it chose to activate that randomness through that process that I mentioned earlier. And by activating that randomness, it's able to engage in new novel behaviors, which again are random, but which may cause it to survive. And so he's showing that this is an example of kind of goal-directed agency. I'm seeing I have a comment. Do babies have free will? Yes. Insofar as they're sentient. But in general, so how I think about free will is it being quantitative, and I think this is the most consistent way to talk about free will. That actually captures the nature of agency and the nature of ability and the nature of being impeded by barriers to whatever it is that you will. So babies have free will, but like overall they don't have much free will, but they probably have more than, let's say, less sophisticated organisms, but still less than like an adult on average. Again, it depends what they're trying to do, because again we always have to talk about free will within a context, and like it kind of just makes no sense to talk about contextless free will unless you're referring to free will as the ability to do things in general. And I think that you and I would agree that an adult can do more things in general compared to a baby, but a baby still has free will. It's just less, at least according to my conception or my conceptualization of this. Okay, so let's continue reading this abstract. The extension targeted by modulation of mutation rate is known to be generally present in biological cells and gives rise to two phenomena that are absent from the non-living world: intrinsic meaning and the ability to initiate goal-directed chains of causation, i.e. active causation. The extended scheme accomplishes this by utilizing randomness modulated by a feedback loop that is itself regulated by evolutionary pressure. So again, it's that combination of randomness. I mean, I feel like this guy in particular goes with that model a lot to explain strongly emergent behaviors. And it is a simple way to demonstrate strong emergence. But what I want to emphasize is that there are other ways to get strong emergence without combining randomness and determinism and deterministic laws. That's one way. That's one particular way to generate a strongly emergent phenomenon, but it isn't the only way. But it is a way to prove that it exists in principle. I see I have another comment. What's the difference between will and free will then? Well, I'll put it like this. Will is the capacity to act on desires, and the free part of free will is the ability to overcome barriers to acting on your desires. And so that's kind of interesting because like you might think like, um, can I fly to the moon? It's like, well, technically yes, but there are a lot of barriers for you to do that. You know, there's a lot of barriers, but you can decrease those barriers by gaining free will in a number of ways. You can study the moon, for instance, and like understand how gravity works and how big the Earth is and exactly what you need to escape the Earth, what conditions are necessary. And by studying that and being conscious of that, you're gaining free will with respect to what it is that you desire. Um, Now, you might have deeper questions about like where your desires come from and whether you're free to choose your desires. Um, and that's something that I will talk about eventually. Um, but I would say that actually, yes, you are free to choose your desires in a lot of cases. And second, it's actually kind of irrelevant to say that like I didn't choose specifically what I desire, therefore I don't have free will. And I'm going to show why that's actually a fallacy with a pretty clever argument, in my opinion. um, um, because it relates again to that concept of quantitative free will. Um, and like if you insist that in order to be free, the only way to be free is to be literally in control of everything that's ever happened to you in the past. In the past, and be responsible for everything that could possibly influence you. That's basically just asking. That's not asking whether you have free will. That's asking whether you're a god or not, whether you're an omnipotent god, because it's basically stipulating that the only way to have free will is to be an omnipotent god. But is that what people mean by free will? Like in most contexts, in most circumstances? Like not really. It's an interesting question, but I don't think it's connected to free will in any meaningful way. Um, Okay, so the mechanism can be extended to behavioral variability as well. So yeah, so first he talks about it in terms of randomness within a cell that's mutating. So just think about like a bacterial cell modifying its own DNA as a result of stresses. So it's being stressed because it's checking its internal representation of itself and checking its environment to see if there's a match, which will determine how fit it is. And if there isn't a match, it's going to start driving up its own mutation rate. But, and of course, that happens in like some single-celled organisms, but it doesn't happen in humans. I mean, it might happen in humans to like in very small scales, like your individual cells might be capable of that. For example, like if you're really hot out, your individual cells might start engaging in random behavior that's meant to find a solution to that. And it's also possible that your gametes, that your sperm cells and egg cells also will undergo modifications in response to stress, with the anticipation that like the current environment is unsuitable for producing children. We need to start mutating these cells, given the possibility that it might lead to an organism that's better suited to the environment. Of course, randomness is always a kind of like a double-edged sword, because you might randomly end up with a mutation that screws you over, but it's still evolution's like solution for trying. I see that I've got a comment. Oh, hey Shadow. Hey, keep it up, man. You got this. Currently at work. I thought I'd pop in and say hi. Best of luck with the studying. Thank you very much, and thanks for popping in from work. Yeah, so let's continue. So so the mechanism could be extended to behavioral variability. A further extension to communication suggests that the active exchange of intrinsic meaning between organisms may be the origin of consciousness. Oh, that's interesting. A further extension to communication suggests that the active exchange of intrinsic meaning between organisms might be the origin of consciousness, in which in combination with active causation can provide a physical basis for the phenomenon of free will. Okay, I gotta see what that extension is. Suggests that an active exchange of intrinsic meaning between organisms may be the origin of consciousness. We gotta see how that works exactly, which in combination with active causation. So active causation and consciousness. I mean, consciousness itself, there's self-consciousness. There's the awareness of one's own self, but then there's also consciousness of the world. And like, it's almost like the fact that you can represent other things in your mind will produce a self-referential paradox with those things. So, for example, right now I'm holding in my hand a crayon, and like I'm conscious of this crayon. It exists within my mind because my mind is producing a replica of it um, inside my own nervous system, but it also exists out here in the world. And it's this relationship between my internal concept and the thing that exists outside the world, which I also think can create a self referential paradox because it's a thing being referred to itself by by my nervous system. Um, and so what I think um, is that the fact that our brains can represent anything will produce a self-referential paradox with respect to those things and be able to produce laws and phenomenon that typically transcend the laws which ordinarily govern how those things are supposed to act. So like my consciousness of this crayon. Normally this crayon falls to the ground in accordance with the laws of gravity. That's kind of like the fundamental law that dictates how this object moves. But I can pick it up and cause it to move in a way that's contrary to that fundamental law because I can represent it in my mind. Or at least being able to represent it in my mind is one component of that. At least I believe. Okay, let's continue. I'm noticing that I don't have any viewers anymore. Maybe people got bored. Which is understandable. I don't feel as energetic as I did yesterday. Maybe because I had a cola. And also my nose is kind of stuffy. So, anyways, let's continue. While the physical world is thought to be governed by mechanistic processes without purpose, the human world can only be understood when meaning and the active pursuit of goals are acknowledged as real phenomena. Now I have a question for you. I don't think anybody's watching, but but if anybody does happen to hear this part, the question is, like, humans have purpose, right? Humans feel like they have agency, and are those things, purpose and agency, real? Or is it only that the physical world is real and these are just kind of like abstractions that our minds create to describe things, but in a more fundamental sense, they're actually just matter. It's actually just matter pushing matter. That's something that I want to know. But like basically the idea of emergence is that something like purpose, because you feel like you have purpose, right? You feel like you can pursue goals. But like, how is it that pure matter can pursue goals? It seems like something that only exists on the human plane of existence. Now, either it actually exists or it's just within our minds and it's just our way of describing something that's just fundamentally just matter being matter. But according to Emergence, it probably does exist. Agency does exist and purpose does exist. These are just emergent phenomena relative to matter. So like matter gave rise to purpose and meaning. It's not that purpose and meaning aren't real. It's that matter can interact in certain ways and give rise in a strongly emergent fashion to things that transcend matter, i.e. purpose and agency. And if you've been listening to what I've been saying yesterday and today, this would also include the concept of evolution. The concept of evolution is not something that matter ordinarily does. It's something that applies to life, that living organisms. It's not something that matter in and of itself is capable of. It's something that living organisms are capable of. And so in that sense, it only exists in the plane of biology. But I don't think any scientist would come here and say that evolution isn't actually real. It is real. It is a real phenomenon. It's just that it's strongly emergent and kind of only applies to a level of existence which isn't the lowest level of existence, which isn't just particles. I can't talk about particles evolving in the same way that I can talk about living organisms evolving. Evolution is something that only applies to organisms, and so in that sense is emergent, and given what we've seen so far, it's almost certainly strongly emergent, because evolution involves both determinism and randomness. And so there's no deterministic way to show what will happen to an organism as it evolves. It just fundamentally transcends pure determinism, and it also transcends pure randomness, because that randomness is being directed towards goal-directed behavior, towards agency-driven behavior. And so in that sense, it's a rather new phenomenon that's very different from how we would understand fundamental particles. The real issue here is that we keep convincing ourselves that if I just understand the smallest components of life, I've equivalently understood everything. Like, I just need to understand how particles interact at the smallest scales, and that's enough to know how everything works. And that's just false. and it's false for very, very cool and interesting reasons. It basically, like, studying all of this has has connected various dots that I've been kind of encountering for a while. I'd say the most interesting of which is undecidability and mathematical undecidability, which I didn't know about until like a few years ago. I mean, I think I'd come across like the Entscheidungsproblem, which is the decision problem in computer science, whether a Turing machine will halt or not. I think I'd seen that before, but I didn't understand the significance of it until like a few years after that. And now I'm starting to see the significance of that for life itself. That life itself can have an element of undecidability, because life itself, or I mean by life itself, I don't mean like biological organisms. I mean like the universe itself, reality itself. If reality itself is governed by mathematical laws, those mathematical laws almost certainly have undecidable truths within those systems. So what do I mean by that? Well, you can take your fundamental particles and then you can put ascribe a mathematical system to them. So like the mathematical system will just be like the laws of physics. So like these particles must follow the laws of physics. Simple enough. The laws of physics are encoded in mathematical relationships. Okay, simple enough as well. Like if I push something, or if I exert a force on something, it'll accelerate. Okay, so there's a mathematical relationship between various properties that I can describe to the fundamental particles, that I can ascribe to the fundamental particles. And so what you have is a mathematical relationship between particles and the way they interact and the way they dynamically behave. But within that mathematical system, this is the crazy thing. Within that mathematical system, there are probably true statements which don't follow from any of the axioms of that mathematical system. So you've described the laws of physics, but then there are laws of physics which will come into existence which are not provable from those fundamental laws. which is crazy to think about, but it must be true. It's true of any mathematical system in just pure math, so it must also be true of the mathematical systems that we use to describe physics. And that's what gives rise to emergent phenomenon. It's the fact that there are true things. Things can be true within a system without necessarily following from the rules of that system, if that makes sense. And if that doesn't make sense, I understand. It's hard to understand. It's a very, very hard thing to understand. But I think it's one of the most enlightening things that I've come across. It's really shown me how it is that the universe can be so weird. Because if you just look objectively at things, this universe is an extremely bizarre place. And there are just these brand new phenomenon popping up all the time. And the question is, like, where do these new phenomenon come from? Do they just follow from the laws of physics? And the answer is no, they don't follow from the laws of physics. They involve laws and principles which transcend physics, which go beyond physics, which can't be proved in terms of physics. And I believe that free will and consciousness are some of these things. And I hope to demonstrate that. I mean, it's, like, in my mind, it's already pretty much shown, because you can show that even simpler systems, way simpler systems, are strongly emergent in this sense. And so if these simpler systems are strongly emergent, any system that comes about from a strongly emergent system must itself be strongly emergent with respect to the fundamental laws. And so in that sense, it must be strong emergence is not rare at all. And if it's not rare at all, we should expect our consciousness to be strongly emergent. It would be extremely weird if our consciousness was weakly emergent. Because weak emergence, like I'll show another paper later on, weak emergence pretty much depends on fundamental laws, but fundamental laws constrain things. They don't enable things. It's hard to actually get from the fundamental laws of physics to like a biological organism. That jump is very difficult to make. But if you incorporate the idea of strong emergence, now you can see how it's possible. Now you can see how it's possible that novel phenomenon arise, because those novel phenomenon are actually going beyond the laws of physics. You don't need to rely on the laws of physics to be able to describe them, because strongly emergent phenomena transcend them. You can't even in principle come up with a strongly emergent property from the the fundamental laws. And I keep saying like the laws of physics, but I really mean whatever fundamental laws you're operating within whatever system it is that you're studying. The laws of physics just being the most relevant here, because that's the angle that I want to approach things from. And it's a very big error to assume that, for instance, the laws of DNA and things that DNA can do are just equivalent to the laws of physics. Because you might think like DNA are physical objects, and they have a particular structure, and so whatever they do is just kind of following the laws of physics. That's actually an error. There's actually a good chance that much of what DNA is capable of doing is actually not describable with the fundamental laws of physics. It's probably a strongly emergent phenomenon. And it even seems like it. DNA is utterly remarkable. If you just know anything about DNA and the molecular structure of DNA and how it is that DNA can give rise to fully fledged organisms, you kind of get this sense that there's something really, really strange about DNA. And to me, this is a strong indication that it is probably strongly emergent. And I think I've discussed enough evidence for that in some of these papers. Okay, so let me stop going on tangents. By the way, if anybody has any questions or any comments at all, please let me know. I'm sure there's lots of questions, but I'm also sure that people won't exactly know what to make of everything that I'm saying. And so, like, even if your question feels dumb, feel free to ask it. Because there's lots of questions to be asked, and I'd be happy to give people insight. Okay, so here I, the author, present a toy model that generates meaning and goal-directedness as adaptations evolvable by Darwinian evolution. The model has direct empirical support from known molecular processes that regulate the mutation rate of biological cells. In particular, behavioral modifications that take place within the lifespan of an organism can be controlled by a similar mechanism, which thus leads to goal-directed behavior with some degree of freedom, i.e., a form of agency. Extending the mechanisms to communication between cells suggests a plausible link with consciousness and free will. I remember reading this paper, but I don't remember this aspect of it being discussed much. Plausible link with consciousness and free will. Okay, we'll have to see. So all of these diagrams are, I don't know if I can describe them in detail because I probably need to go back to the original paper. Let's see. Let me just see if I can look at my notes. N of HT, where is that? Is that in this diagram? No, I do see N of T. Okay, N of HT, number of organisms with hereditary type H at time T. Yeah. Oh, there it is. N of HT. There it is. Okay. TH is the lifetime of the organisms. That's over here in this square. Alpha of HT is the fitness of the basically the number of offspring that the organism produces. I don't know how. If you guys are listening, do you think I should describe this whole thing and what each of these elements is, or? I mean, I feel like I understand it, so I don't need to go into it in too much detail. Okay, I'll just read the notes instead because that's probably more interesting for you guys. But basically, all of these diagrams are just showing how this system that he constructed, which again is based on real things, like real cells, they're real cells that pretty much are governed by these laws, how strongly emergent phenomenon can occur from these. So again, strongly emergent phenomenon isn't theoretical. It's definitely doable in theory, and it almost certainly exists in real life because we know that there are organisms that have these systems. Okay. This is probably my own note. Describes all the components of evolution and then says that this process has no goals. It just evolves and happens to develop more advantageous traits. But then you can slightly extend it to change it dramatically by considering organisms that have some control over their own mutation rate. So this is interesting because, again, you can see evolution as something that just happens to happen. Like an organism happens to have the genes that survive, and so it reproduces, and then its offspring happen to also have those genes, and that just continues on, and there's no goal-directedness. But if an organism has the capacity to change its own mutation rate, and again, there are cells, single-celled bacterial organisms that are capable of this. There are probably also protists and what's the category of life that I think it's protists. There are basically just single-celled organisms that are capable of altering their own mutation rate whenever things are stressful for them. And so this ability to control their own mutation rate is starting to look like agency. because an organism feels that it's not likely to survive, and so it starts. It initiates a chain reaction, which leads to this random process, in the hopes that this random process will generate something useful for the organism. And that can be anything. So, like, if I get to a specific example, like if a cell is in a particular medium and it can't digest that medium, so like it's looking for food, but it can't see anything that's food. So maybe it tries to randomly alter its own DNA such that an enzyme is produced that it can use to metabolize that food. There's a very low probability of it occurring, but if you imagine there being like millions of bacteria in this medium, there's a chance that at least one of them might produce the proper mutation and then get something useful. And then once it gets something useful, it can turn off that mechanism. This is very key. It has the ability to turn off that mechanism, which causes random mutations if its survival prospects are relatively high with respect to its environment. So it's that ability to control things, which is starting to look like something similar to free will. I wouldn't say it's exactly free will, but it is agency. Like it is, if you think about the organism as a holistic entity, the holistic entity is expressing something that most of us would consider to be compatible with the concept of agency. No, so yeah, okay. So such controls exist as a general feature of cells. Observable as increased mutation rates in cells under stress, for example, because of a shortage of nutrients or the presence of toxins. Although a higher mutation rate produces many non-viable offspring, it also increases the probability of a mutation that lets its carriers survive the stress, multiply, and thereby increase the chances that at least one of its lines of descent will survive. Exactly, yeah. He did a simulation comparing those with a fixed rate of mutation to those that could alter their own mutation rate. And what he showed was that the variable rate of mutation, so organisms that had the ability to alter their own rate of mutation, outcompeted those with a fixed mutation rate. So it's just showing, well, this shows a couple things, that like having control over your own internal processes is better for survival. So this could show that if free will exists, it's better to have free will than to not have free will. So if we posit that evolution can produce something like free will, it's going to try to increase the organism's free will, and that's what I think evolution does. Like evolution over time produces more sophisticated forms of sentience, which are better capable of one, monitoring the external environment, and two, monitoring the internal state of the organism. The better these systems are, the more efficient they are, and the better the information that results from them is, the better the chances are of the organism surviving. Although these systems tend to be rather computationally and energetically pretty much you have to consume a lot of energy to be able to utilize these systems, and that's a trade-off. And so again, it's a balancing act between having an efficient nervous system and having the proper rate of energy consumption that isn't too taxing on the organism. Okay, so although organisms, I should probably speed through this paper because the next one is more interesting, like way more interesting, and really what I need to study today. Although organisms indeed appear to spend a significant part of their physiology and neural resources on inferring the states of themselves and their environment, for example, their internal nutritional state or dangerous external factors. That's a good example. Like, you feeling hungry is you sensing your body's own internal state. And if you can represent your body's own internal state, you can utilize a kind of self-referential paradox to transcend laws which you would ordinarily, let's say govern the way the fundamental constituents of your body are meant to interact. You can transcend those laws, so to speak. Hello to my 3 viewers, by the way. If any of you want to say anything or jump in and give a comment, feel free to do so. So, for example, their internal nutritional state or dangerous external factors. Producing the estimate ultimately requires evolved heuristics, shortcuts, and rules of thumb. That's pretty much a good principle in psychology in general, that our brains don't represent reality accurately. They represent it in a way that's most useful to us. Um, and that kind of useful shortcutted version of reality saves energy because you don't have to spend too much time processing like individual details. You just kind of see basic symbols, and that gives you enough information to react. So let me blow my nose, and that'll give you an example. An example would be like, for example, you're in the woods, and then you suddenly come across something moving that has teeth. Now, you can either spend all of your brain energy analyzing what that thing is, or you can just use those subtle hints to come to the conclusion that whatever this is, it's probably dangerous. I need to run. And so it's just a shortcut. Like, it's a behavioral shortcut. You don't have to perceive your entire environment or like an entire aspect of that environment to be able to do it. One is me. Hi. Hey, watch me do stuff. How are you doing? Yeah, thanks for commenting and letting me know that there are people watching. Okay, let's continue. Causation in nature can be quite complex, but it is useful to distinguish two basic variants: deterministic and stochastic causation. So deterministic is straightforward, I hope. Stochastic is actually random. Stochastic and random are synonyms. I guess it's just a better way to talk about randomness. Stochastic. I mean, it sounds nicer as well. But stochastic causation is just randomness. And again, the principle here, I've said it multiple times at this point, but the principle here is that if you combine randomness with determinism in a very specific way, you can get strongly emergent properties that you can't predict using the fundamental rules of whatever system you're operating in. It's transcendent. And it's provably transcendent. Like, it's in principle impossible to get those properties. Evolution is one example. Evolution is a thing that happens to organisms, but there's no way to use the laws of physics to derive the principle of evolution. You might be skeptical of that, but this guy pretty much proves it. Like, he proves that evolution itself must be a strongly emergent phenomenon. And another paper by George Ellis, which I'm going to read soon, showed exactly the same results. So this has been verified by multiple different sources and different scientists. Okay, in deterministic causation, systems evolve in a predictable way, with one part of the system influenced by and influencing other parts through fixed relationships. Chains of causation are mere continuation of existing chains. No new chains are started. In stochastic causation, new chains of causation are initiated by definition because the stochastic variables have no specific identifiable cause, i.e. they're random. Physical sources of stochastic causation are thermal and quantum noise. This quantum noise is, I think, like probably the most fundamental source of randomness in the universe. Thermal and quantum noise, and thermal noise is indeed the primary source of stochasticity for mutations. I guess that applies to DNA, that random mutations in DNA are caused by thermal noise. Although I believe there's a lot of things that cause random mutations, like the sun even. Okay, watch me do stuff. Currently eating cornmeal, nice. Trying to get in lots of fast-acting carbs because it can help relieve muscle soreness, and my brain can focus on paperwork even though I'm sore from weightlifting yesterday, aiming for 200 grams of carbs. Okay, well, good luck with that, and I hope you can get your paperwork done. And I hope I'm not too distracting for this. Or that I'm not consuming too much of your brain's energy, because this is consuming a crap ton of my brain's energy, just trying to comprehend this and articulate it, which is why I'm studying it, and I'm studying it live on YouTube for people to listen to. Don't worry, this will eventually be turned into like an actual video once I understand what's going on fully. Hopefully I can write it tomorrow. I'll try to write it tomorrow since I'm free tomorrow. Or then maybe film it the next day and then post it Saturday. That's the goal for now. But it might be a while, and I don't even know if this is worth making a video about because it's so complicated that I feel like most people are just going to check out really early. So you will see. We'll see. Siamini says, I'm playing chess while listening to you. No, this relates to what you were saying about relating to you saying listening to your body and trying to be better. Right. I think we talked about that before. Yeah. Um, and it very much does relate to that because this whole thing is about organisms that have some capacity to represent themselves internally. And if you can represent yourself internally, what you can show is mathematically is that you can develop a relationship between yourself that is transcendent of the rules of mathematics that govern your fundamental constituents, i.e., the matter that makes up your body. Very cool, very interesting, very weird, but totally mathematically consistent, mathematically proven, and more evidence is showing that this is a real phenomenon that occurs in real life, not just in math. Although I would argue that if a phenomenon occurs in math, that's like the most fundamental level for it to occur. And if it occurs at that level, it almost certainly occurs in reality. Now, again, I'm not saying that everything in math corresponds to reality, but this is a very fundamental thing in math. Like it's as fundamental as like you add two numbers. Like if I add a plus b, it's the same as b plus a. Like something that fundamental is pretty much what we're talking about with respect to incompleteness. And so something that fundamental is almost certainly an aspect of reality and not just like a something that we find in the math. And there's plenty of proof for that. And I'll go through the proof. This paper is proof of it, and the next paper is proof of it. Okay, if there is an estimate of fitness, it produces modulated stochastic. Did I read this physical? Yeah. If there is an estimate of fitness, it produces modulated stochastic causation. So, modulated stochastic causation, again, is that combination of determinism and randomness. The function estimating fitness mixes deterministic causation with stochastic determination. Yeah. The result is that the deterministic and stochastic causation becomes thoroughly entangled. Fitness at a particular point in time is dependent on the complete fitness history of the lineage. And so in that sense is deterministically caused by the the previous generations of that organism's history. So the past is relevant here. It's not just like pure randomness. Things that happened in the past are having an influence on the future, but not entirely so. There's also this random process that's making perfect prediction from the past impossible. Hence why it's strongly emergent. Fitness on the lineage and thereby on the history of the environment. So the environment is also important, and on the complete history of the realizations of mutational stochasticity. This type of stochasticity is different from typical Darwinian evolution because the complete history of fitness is relevant. This is a unique form of causation midway between stochastic and deterministic. Again, it's not merely deterministic or stochastic. It's like this special type of causation that's occurring when you combine the two in this particular way. Again, it's very difficult to get that concept across because I feel like, again, when I'm in the future, when I'm debating Sam Harris about this, at least I hope to, he's just going to say like randomness or determinism neither gets you free will, and there's no way to combine them such that you get free will. But that's false. You can combine them in such a way that you get free will. Because if you combine them in a certain way, you can get a strongly emergent phenomenon which no longer plays nicely with the rules, with the I need to find a better way to say this. I keep saying like with the rules that govern the fundamental constituents, which is a nice way to word it, but I feel like I keep saying that over and over again and want to find a better way to word it. Moving on, in contrast, the entangled form of causation described here will be called active causation because of the crucial role the organisms of the organisms of a lineage play in steering stochasticity, therefore in steering the resulting hereditary trajectories as shown below. Because again, the organisms themselves decide whether to activate or deactivate the random rate of mutations. They can increase the random rate of mutations, or they can decrease them. And so the organism itself is playing a role in shaping its own destiny, which, I mean, doesn't that sound a lot like free will? Okay, each step is random and thus provides an element of unpredictability, but the trajectory as a whole is not random. First, it makes high fitness a genuine goal of the organisms in a lineage, and second, it gives them, through their lineage, an active role in its destiny. High fitness as a genuine goal. So this is the emergence of goal-directed behavior. Every organism seeks to be fit. seeks to have high fitness. And again, high fitness in this paper is defined by rate of reproduction. So the amount of offspring that you can produce. Every organism attempts to produce as much offspring as possible, or to be in a state that's consistent with the highest production of offspring possible. So this can also be extended to behavior rather than mutations. Exactly, organisms actively changing their behavior in response to changes in fitness, and its behaviors are not totally random, but an attempt to align itself with F. F is fitness. The feedback scheme also produces active causation as before, but now on behavioral timescale. This produces a form of active agency in the organism, with some behavioral freedom produced because the unpredictability of behavior is associated with stochasticity. The unpredictability of behavior is associated with the unpredictability of behavior associated with stochasticity is modulated and thus partly controlled by the organism itself. Organisms with advanced nervous systems can go further by mentally simulating the expected consequences of behavior change and checking alternatives before picking a course. Simulations show that this strategy is the best. Okay, so this was a very interesting point that came up in the paper, in which I've mentioned it. So I mentioned it last time in my discussion on the connection between free will and consciousness, because consciousness is capable of like creating mental simulations of things. So like you need to go somewhere, and then you like think of 3 possible ways for getting there, and then you simulate them in your head. So I can either take the bus there, I can walk there, I can drive there, or I can take an Uber. And I simulate these in my head and I consider them. And again, a simulation isn't necessarily me imagining it happening, but it's me considering it happening and considering all of like the variables involved. And after I do that, after I've mentally simulated my external environment within my internal structure, my internal nervous system, I can then pick a course. So I created this abstract thing inside my own brain, and then I'm using that abstract thing to make decisions in the real world. This is completely unpredictable by pure materialism, because how can materialism predict or make sense of the idea of an abstract idea? It just simply doesn't fit into the model of materialism, and it doesn't fit because it's an emergent property. So in principle, you can't get from the rules of material causation to consciousness. Just in principle, it doesn't work. And so this is an example of free will, and maybe even an example of how to increase your free will. So if you want to do something, just think about it. think about a plan for doing it. And by making a plan, you're basically just like mentally simulating what's going to happen in the real world. And then if you find an adequate simulation, you can act on that plan, thereby exerting your agency and thereby exerting your free will. Let me take a drink of water and also take a few deep breaths because I'm starting to notice how energetically intensive this is to just think about this and talk about this. I see Watch Me Do Stuff said something. What you just said about this relates to multiple universes theory, in that we are biological, but we think, okay, what if we turn left and go to work instead? I believe all of this relates to the avoidance of possibly passing away. Oh yeah, definitely. Well, yeah. I mean, at a fundamental level, it might just be like the if you're saying possibly passing away as in possibly dying, it just finding maybe like that's the fundamental drive within an organism, is to just not die. But I would not ever see this as like a as something that defeats free will, because like if you have the will to survive, the question is that will to survive free or not? And I think it is free, as a way to avoid at all costs. So we think of the mathematical world being ones and zeros. Not sure what you're saying there exactly. As a way to avoid at all costs, so we think of the mathematical world as being ones and zeros. I mean, that's the simplest way to model it, in computers, especially all the computers that we use. Okay, moving on. So this happens unconsciously. I think I'm trying to say unconsciously. Yeah, that could be the case. Um, okay. So yeah, this is a very, I should highlight this because that's very interesting in my opinion. Finally, organisms may communicate in order to coordinate their behavior and thereby increase fitness. Like I can spend a while talking about this as well, but hopefully it's just self-evident what that means is that like I can increase your fitness by giving you information. Like if I have kids, like I'm going to teach them about the world in order to increase their fitness, which is a directed process, which is an agency-driven process. So we adjust if we fail or succeed. Excuse me, as a collective. That's why we are so advanced today. Mm-hmm. Um. Okay. Let's. Where's the thing? Okay. Yeah. So let's move on to this paragraph. Intrinsic meaning is a real phenomenon. Definitely so. So yeah. So here's a question. Since I have 5 audience members, here's a question that I'm going to pose to you guys. Do you consider meaning to be a real phenomenon or just something that like human brains generate for like for our own purposes? Is it real or not? I would say that our brains generate the idea of meaning, but meaning is also real. Like it's both. That's my opinion. And emergence explains where meaning comes from. It's an emergent phenomenon. There's no way to describe meaning in terms of electrons and protons. Meaning is something that arises at a higher level of existence, which is unrelated to what's happening at the lower levels. So intrinsic, you think meaning is not real? Wow. Why did I just open Excel? I know I have an interesting proposition, something I've been thinking about for a while. Sorry if it throws you off a bit. Well, no worries. No worries. Yeah. Like this topic itself is like so mentally draining that I'm probably going to be off as I describe it. But the whole reason I'm describing it and I'm talking about it right now is because to give you some context, basically for the past like week, it's almost been a week now, I've been studying this topic of strong emergence. And trying to get to the bottom of it. And so I've been going through multiple research papers that discuss it. And what I've found has been truly, truly enlightening and truly interesting. On another level. Like this is probably like such a key feature of existence and explaining why existence is the way it is. It's also kind of scary to think about it. Because one consequence of this is, okay, so imagine like an emergent phenomenon in the context of sentience. So like imagine qualia, like the qualia of color. Okay? We can experience a whole bunch of colors, but then we also know that there's colors that we can't see. And here's the question. In the current state of the universe, do all colors that could possibly exist or that we could possibly evolve the ability to see, do all such colors already exist in the universe or not? Strong emergence and the theory of strong emergence pretty much states that there isn't a limit on the number of colors that exist in the universe. As we evolve, as we continue to evolve, more and more colors will continue to exist, and this can go on for infinity. As far as we can tell, it could go on for infinity. There's an infinite number of colors because colors are emergent, and so there's never an end you can get to in terms of the new colors that you can get. And so in that sense, all of the colors that could possibly exist don't even exist yet. And you can never make a full list of all the colors that exist because you can show that within all of those colors, there's a new color that can exist out of those colors. Which is totally insane, which means that there could be an infinity of the number of colors that exist in the universe if strong emergence is true. So yeah, maybe if it's draining, there's a reason to it. Being so draining, meaning not that you're not necessarily supposed to know, but yet something you only want to focus on a little bit as you live your life. I mean, this in and of itself is like the lifelong work of some people. And I'm just here to like scoop up their insights and learn from them. And you bring up an interesting point because I don't really want this to be the focus of my life, but it is right now. And the fact is, like, I can understand it. Like, because I can understand this topic decently well, I feel almost like obliged to understand it because so many people have never come across this. and it's very unlikely that they'll be able to understand it. But we've reached a point where I think a lot of people are now capable of understanding this topic. Because ideas like undecidability have become more like mainstream, especially these days. Like people, like, it's very common to find young people who understand the principles of computer science, understand coding, understand logic, and neural networks, and all the kind of sorts of things you can do with computers, especially with AI getting so popular. And so the idea of undecidability is something that people should be more and more familiar with. And so what I'm describing, which depends on undecidability, should be fairly easy to understand as long as you understand undecidability. And so, yeah, one thing I recommend is that if you don't know what I'm talking about, just Google or just go on YouTube and look up incompleteness theorem or undecidability. I think incompleteness theorem is probably the best way to go for it, because that's like the fundamental theorem that shows undecidability, that gets you to undecidability, and gets you to self-referential paradoxes. Now let us continue. Okay. Intrinsic meaning is a real phenomenon on par with any other aspect of the physical world, even if it only occurs in specialized living forms of matter. In most organisms, it is presumably present only implicitly. In most organisms, it is presumably present only implicitly, distributed over many variables. That's definitely the case for our brains. However, once it becomes a part of a dialogue, it needs to be made explicit and coded into behavior. And the other organism needs to perceive and decode it. So this is just like language and like the transfer of meaning and explaining even like the meaning of language, the meaning of words, like the feeling that words have meaning, is an emergent phenomenon. Language is an emergent phenomenon. And it's a crazy emergent phenomenon. Anybody who spends enough time studying language, the structure of language, and like thinks about like how is it even possible that I can like make sounds, and like me making sounds is causing meaning to occur in your head, and you know what I'm talking about, and you understand the words that I'm talking about. Like, what? That's a crazy thing, and yet it's definitely an emergent phenomenon, probably a strongly emergent phenomenon given how common strong emergence is. And assimilate it into its own intrinsic meaning. I conjecture that the process of extracting and assimilating intrinsic meaning during dialogue manifests itself as consciousness. The intuition here is that transfer of a real physical phenomenon, intrinsic meaning, gives rise to another real physical phenomenon, consciousness, somewhat analogous to how transfer of charge gives rise to a magnetic field, even without an actual current, as in Maxwell's displacement current. Initially, occurring only between two individuals, it may gradually extend through development and learning to more complex forms, such as nonverbal dialogue with another individual about objects, nonverbal dialogue with internalized versions of others, and the shared world, and with an internalized version of the self. This is showing that like your internal monologue, like, yeah, like, okay, so at first the language is used for communicating with other people, but then language also becomes this thing within our own minds that our own minds can use to understand the world. Not necessarily the best way to understand the world, if you know the master and his emissary, that language can actually cause this kind of big filter on your perceptions, which prevents you from seeing what's really there. But it's still this new thing that's occurring out of a phenomenon which is originally used for communication. So it just shows how like a different system can utilize the rules that have emerged from a different system, which is that in and of itself is another crazy thing. Okay, so the scope for exchanging intrinsic meaning obviously expands considerably once the transition from nonverbal to verbal dialogue is made. Finally, the combination of consciousness and active goal-directed behavior and dialogue can provide a physical mechanism for free will. So apart from like the obvious implications of this statement, which is that it's in line with what I've been saying on my channel for a while, It's also interesting because it's basically referring to these multiple strongly emergent phenomenon, consciousness, active goal-directed behavior, and dialogue in the form of language. You can take these three things and you can combine them in such a way. And remember, each of these things is itself strongly emergent from other phenomenon. You can take each of these things and this can give you a mechanism for a new strongly emergent phenomenon, which is free will. Okay. Now I'm gonna mention this, even though this is hard to understand, but bear with me. So okay, how do I explain this? Basically, you can make a system that has as its components consciousness, goal-directed behavior, and dialogue. Okay, you can take those three things and make a system out of it. Okay, now those three things might be strongly emergent, but you can show weakly emergent phenomenon as a consequence of these three things. Okay, does that make sense? So new phenomenon can emerge from these phenomena that are either weakly emergent relative to the system or strongly emergent relative to the system. In an absolute sense, they might be strongly emergent. So because, like, for example, consciousness is itself strongly emergent from matter. So overall, the system is strongly emergent with respect to matter. But let's just say you made a system out of consciousness, goal-directed behavior, and dialogue. Within that system, you can show that there are weakly emergent phenomenon. Free will might be weakly emergent from those, but free will might also be strongly emergent from those. But in a more absolute sense, free will must be strongly emergent from matter. Does that make sense? Like, it can be weakly emergent from these principles, but since these principles themselves are strongly emergent from matter, free will should itself be strongly emergent from matter. And that's all we're trying to show. I don't need to show that free will is strongly emergent with respect to a system that I construct. I just need to show that it's strongly emergent with respect to matter, because that's the fundamental argument for determinism, for causal determinism, is that if the universe is just matter pushing matter around, there's nothing I can do that's unpredictable, because I just have to apply the standard model Lagrangian to all of the matter in my body, and then I'll just get a model of my behavior, and nothing I do will be apart from that. But the reason that this is false is because my consciousness is a strongly emergent phenomenon, which is itself not predictable from matter, and then my free will might be a further consequent of that consciousness, which itself won't be predictable from matter. Hence, free will is totally possible. I notice I have a comment. Hold on. YouTube isn't showing me my new comments. Okay, what is the difference between something that is strongly emergent and weakly emergent? Great question. Okay, so where do I go? Okay, I don't know. It's hard to explain, but I think I'll do it through like analogies and examples. Something is weakly emergent if it follows from the laws of whatever system you're talking about. And it's predictable given those laws. Okay, so as an example, let's take the laws of physics. So the best model of physics that we have at the most fundamental level is the standard model of particles. This tells us what particles are. It also tells us how they interact, what forces they interact on each other. Okay, now. So the standard model has, for example, it has up quarks and down quarks. And if you cause those up quarks and down quarks to interact in a certain way, you get a proton. A proton is composed of two up quarks and a down quark. Okay. Now a proton, I believe, is a weakly emergent phenomenon, because you can look at the laws of physics and you can see, I can see how it is that a proton can emerge from the fundamental laws of physics. So it's weakly emergent. It's this new phenomenon. It's a brand new phenomenon, but it follows from the laws of physics. Okay? Simple enough. A strongly emergent phenomenon is some kind of phenomenon that seems to arise out of the laws of physics, but there's no way, even in principle, to derive it from the laws of physics. So there's no way and there's real examples of this. So for example, I'll go later. I'm trying to get to the next paper, which will discuss an example of strong emergence, which is very interesting, which occurs in semiconductors. So what's happening in semiconductors is that you have you have a crystal structure. And this crystal structure, it appears that it has properties which are not predictable from the laws of the particles that make up that crystal structure. Not only that, this is another aspect of strong emergence. Not only that, but that those higher laws, those higher properties, are somehow having an influence on those fundamental properties. So the laws of physics themselves are being altered by this new phenomenon, which is like, what the hell? How is that happening? But if you think about it, and if you think about my model of free will that I've been proposing so far, this is completely consistent, because what I'm saying is free will, or rather consciousness, or rather more specifically sentience. Sentience is this new thing that has emerged as a consequence of matter interacting with matter. And now that this higher thing has emerged, it has this downward influence upon the laws of physics. So now I can cause matter to act in ways which are contrary to the laws of physics as we understand them, because there's this new, higher, strongly emergent property that has evolved out of that matter. Now, does that answer your question? Does that like fully characterize it? There's more aspects to it. For example, there's the computational aspect of it, which is pretty much, if you're familiar with the concept of incompleteness, it's pretty much that, let's just say I have a mathematical system that describes my physics. Basically, a strongly emergent property is something that's true within that system, which can't be proven through the system. So it's this like additional truth. And once this additional truth is added to your system, you can get brand new properties. And again, none of those properties will be predictable from your lower level system. They're only predictable when you add these new properties to your system, but you can't find those properties within your system. You just have to kind of observe them and then add them to your system. There's a great example. Oh, no, I won't get into the example yet. But does that answer your question? I hope it does. I notice I have 8 viewers now, which is the highest I've had so far. If anybody has questions about what I'm discussing, please feel free to ask, because this is a lot of fun to discuss, and I hope I'm making sense. And if I'm not making sense, please let me know, and then I'll try to readjust my descriptions. Okay, so let's move on. Where was I? Yeah, okay. The models presented here show how life can evolve two phenomena that are absent from the non-living world, but appear to be present in all current forms of life, i.e. emergence. So like so in this particular example, he's talking about agency, and I think it's like, hold on, not agency, basically goal-directed behavior. He's showing how goal-directed behavior is not something that atoms can do. Like, just think about it. Like, just think about an arbitrary set of atoms. Like, do atoms have goal-directed behavior? No, they just kind of inert objects. Living things can have goal-directed behavior because goal-directed behavior is emergent. So it doesn't exist on the plane of atoms, but it does exist on the plane of living organisms. And so you have these different levels of existence. Hold on, I might have deleted it, but I had this really cool, here, I'll just click on the link. No, I might have deleted the link as well. But there was this diagram that kind of shows how this process works, that like within these different kind of levels of reality, you can have higher and higher emergent phenomenon that have a downward influence on the lower levels of reality, which is like this reciprocal causation. It's not just that I can influence matter. Matter is also influencing me. So there's this like cyclical relationship between me and the matter that composes my body, or even like the matter that composes the universe. But that doesn't mean that I'm just entirely governed by matter. Like, I can go beyond it. I can do things that the matter itself doesn't ordinarily do of its own volition. Like, because of the principle of emergence. First, it evolved a form of active causation. So active causation is an emergent property which living organisms can have, which, again, atoms themselves don't have. Enabling organismal lineages and organisms to initiate and pursue trajectories of heredity, behavior, planned behavior, and dialogue. Second, life evolved intrinsic meaning. That's the other thing. Meaning. Meaning is itself an emergent phenomenon.
meaning doesn't make sense with respect to atoms, but it does make sense with respect to humans. So think about language, for example. Like you're listening to me talk and you're reading the words on the screen and you understand what they mean. Meaning isn't something that atoms can just do. It's something which living organisms, i.e. humans, can do. And so meaning in that sense is an emergent phenomenon. And this paper shows that it's strongly emergent. The mechanism that he describes here, and he goes through all these diagrams, like this is part of it. And there's like different modifications of it. But basically this system describes a living organism where the concepts of agency and meaning can emerge. And so it's totally grounded. It's not just like a theoretical concept. It's totally grounded. You can show that it emerges in certain systems, in certain sophisticated systems. And these systems are very similar to life itself. So it's very, very reasonable to put forth that these strongly emergent phenomenon, which exist in theory, also exist in living organisms. It would be very strange if they didn't. It would be very strange to be able to produce simple systems that show strong emergence, while strong emergence itself doesn't exist. And anyways, like I don't need to be convinced because I've seen the evidence, having read all these papers. Okay, where was I? Okay. Yeah, so in this particular case, second, life evolved intrinsic meaning as embodied in the way organisms estimate their own fitness. So if an organism can estimate its own fitness, first of all, that's a self-referential paradox, which means that whatever mathematical laws you use to describe it, there's going to be things that transcend it. But also the fact that it can refer to itself is a condition for meaning to exist. The arguments presented here suggest that agency and intrinsic meaning are emergent properties when hereditary or behavioral variability is based on an organism's estimation of its own fitness. I mean, now everybody think about this. All my 8 viewers, think about this. Are you able to estimate your own fitness? Okay, if you're in the comfort of your own house right now, you're probably very fit for that environment. But imagine I suddenly dropped you off in the sketchiest city, the sketchiest, most impoverished city at nighttime. You would immediately feel uncomfortable. And this is an example of you testing or determining your own fitness. You can tell right away, I am not fit for this environment. And then that'll cause behavioral modifications. So your ability to represent yourself with respect to your environment is what gives you the ability to change your behavior in order to match your fitness or attempt to match your fitness with your environment. So you find yourself in that situation, you immediately leave and go somewhere else, and then maybe that'll increase your fitness. So with respect to hereditary variability, this is closely related to second-order selection for properties enhancing evolutionary potential. However, when this selection works, for example, on mutator alleles, with the hindsight of natural selection, the causation is merely passive. In the extended scheme of figure 1c, let's just quickly check figure 1c for a second. Just for my own sake. Not that you guys will understand it. Okay, yeah. In the extended scheme of figure 1c, causation is active because it involves a predictive estimate of fitness made by the lineage's organisms themselves and utilized in a feedback loop that transforms the randomness of hereditary change into goal-driven hereditary trajectories. Similarly, a behavioral feedback loop incorporating self-estimated fitness leads to goal-driven behavioral trajectories of an organism. Yeah, that's pretty much exactly what we've been talking about. Or if you lose your social status and become homeless, would that affect your fitness? Well, that's a more specific example of the more general idea of you being able to determine your fitness. So yeah, of course that would affect your fitness. But the key thing is that you can tell, I've lost my social status, so I know that my fitness has been affected. That allows you to make behavioral changes to increase your fitness. Same thing with social status. And if you keep failing to adjust to the environment, what can you do? Keep attempting to adjust. Like what else are you going to do? Because if you stop trying to adjust, you're just not going to be fit. And And as I mentioned before, computer simulations have shown that organisms, very simple organisms that have this capacity, outcompete organisms that don't have this capacity. And so it's very much a something that organisms have evolved to survive, utilizing both determinism and randomness. Okay, let's continue. The models presented here took inspiration from so-called two-stage models of free will proposed by many researchers going back at least to William James. Oh, okay. That's good to know. Maybe I'll look for William James's argument for free will. I mean, I doubt I even need it because I've been noticing, like, there's a paper down here that pretty much reiterates all of my positions on free will except in terms of undecidability. And that undecidability is something new and something that I'm going to have to consider in the future. But he pretty much states what I've been stating, just in different words. So a lot of people have come to this conclusion. So it's not just me who's like the only person who's arguing for the existence of free will. A lot of people are, and a lot of people have come up with very good arguments. It's just that in the current, I guess, intellectual environment, it's very popular to posit that there is no free will, and that position is very much backed up by causal determinism. But again, what I'm trying to show is that causal determinism is in a sense false because of emergence. Comment. So does fitness relate to competitiveness? Yes, it does. Because it can be hard to find a niche. Yeah, exactly. Very much, it is competitiveness. It's in this context pretty much defined as your propensity to have offspring, which is exactly what competitiveness is. Again, it's totally biological, totally evolutionary. Okay, it is sometimes assumed that any observed stochasticity in the world is not real, but only apparent, caused by a lack of complete knowledge of the underlying causes of the observables. The models and arguments presented in this article, that's a very key point, by the way, to consider, so please keep that in mind. The models and arguments presented in this article are agnostic with respect to the source and nature of the stochasticity required, and are therefore not affected by any such assumptions. Nevertheless, at a deeper level, it might be argued that if stochasticity is only apparent, the freedom provided by active causation is only apparent as well. So, like, that's a good argument or, like, a point to address. Like, is the randomness really random, or is it just, like, pseudo-random? And responses can vary from, like, even if it's, like, pseudo-random, that might be random enough, you know? Alternatively, you can say that there is genuine randomness, for example, in quantum mechanics. I believe that such a view is likely to be mistaken for several reasons. First, the as-if stochasticity argument ignores quantum indeterminacy, which appears to be a genuine source of randomness. Second, the argument is often based on the theoretical assumption that current physical theories have unlimited validity, whereas these theories are known to be incomplete. And there we go. These theories are known to be incomplete. The laws of physics themselves, which people make to argue for, the laws of physics themselves, which people refer to make arguments in favor of causal determinism, are themselves incomplete. So how can you use them to disprove the existence of free will when they themselves are incomplete? They themselves have truths within them that are not determinable by those laws. So if you say that everything is determined, you're just ignoring the fact that that's just fundamental, at the most fundamental level, not true. Because there are going to be things that are not determined by your system of math, by your system of physics. So, I mean, it's great. I have a lot of, by studying this, I have a lot of arguments up my sleeve against causal determinism. One of them being that, like, even the laws of physics that are commonly accepted as, like, the fundamental rules of physics, they themselves cannot be the fundamental theory. They themselves are incomplete. Like people often say that the standard model of particle physics is like the fundamental theory, like the source of everything. We know that it can't be the source of everything because it doesn't work with gravity. It's incomplete. It's false at some level. I mean, it's obviously right in many ways, but it's obviously also wrong in many ways because it doesn't work with gravity. And gravity clearly exists. So that in and of itself is kind of a hole in the reductionist argument. Um, Okay, and it is not clear how far they being these fundamental theories, can be extrapolated beyond their range where they have been tested. Finally, in a classical Newtonian universe, even Laplace's demon gets confused. With a tiny fraction of a second, if the whereabouts of a merely single electron are unknown. So Laplace's demon, I'm not sure exactly what this means, gets confused if it doesn't know the position of one single electron. I'm sure there's more to unpack there. Arguing that microscopic fluctuations cannot show at microscopic scales. Sorry, arguing that microscopic fluctuations cannot show at macroscopic scales because they average out is not valid either, because nonlinearities can easily amplify even the smallest indeterminacies to prominence. Yeah, okay. So that's all about randomness and the source of randomness and where randomness comes from. I'm of the position that even pseudo randomness should be considered a kind of form of randomness with respect to a given system. Okay, let's think of an example. So for example, sunlight is known to affect the rate of mutations. So if sunlight hits my gamete producing organs, i.e. my testicles, that might cause mutations in my sperm cells. Those mutations are kind of like random from a Darwinian sense. But like in the more general materialistic sense, they weren't random because you can predict the trajectory of photons coming from the sun, and you can tell exactly how they hit my balls. And so in that sense, it's not random. But I think on the scale of living organisms, you should still consider it random. Like on the scale of the universe as a whole, maybe it's not random, but on the scale of a living organism, it's a kind of randomness with respect to that system. It's not something within that system. It's something from the outside of that system influencing it in a way that's totally random and you can't predict the trajectory of it. And so in that sense, I believe that randomness is real. Okay, so I think I'm going to read the abstract of this paper. This has been my favorite paper. Or actually, there's been a bunch of good ones. The next 4 papers after this one are among my favorite that I've looked at so far. I read a whole bunch of this guy's papers, but I only had to read one of them. So might have wasted time there. But when you're doing research, a lot of what you do will end up being wasting time because you don't know whether the thing that you're oops, I just noticed I got a call from someone. If anybody heard my phone buzzing, because I'm really bad at hearing it, let me know. Okay. Why aren't these texts going through? That's weird. Okay, there we go. Okay. Okay, so I'm going to read the abstract of this next paper, and then I think I'm going to take a break and come back later because I haven't gotten through what I want to get through, but at the same time, I'm starting to feel tired. So maybe I'll just eat dinner and then come back and continue studying. I hope people don't mind that there's multiple uploads to my channel just from YouTube Live. But anyways, here we go. There has been much controversy over weak... This will be a good summary as well of what we've discussed so far. There has been much controversy over weak and strong emergence in physics and biology. As pointed out by Phil Anderson in many papers, this guy's a genius from what I've seen, the existence of broken symmetries is the key to emergence of properties in much of solid-state physics. By carefully distinguishing between different types of symmetry breaking and tracing the relation between broken symmetries at micro and macro scales, I demonstrate that the emergence of the properties of semiconductors is a case of strong emergence. This is due to the existence... semiconductors, which is something that you're using right now to watch this video, and the properties of them are strongly emergent properties, proven to be strongly emergent properties. Like there's math that backs up that these are strongly emergent properties. This is due to the existence of quasi-particles known as phonons. Very interesting is that these phonons, like they don't exist in fundamental physics, but they start to exist as a consequence of this crystal structure. So like this brand new phenomenon is occurring, and this brand new phenomenon is able to influence matter at the smallest scales, which is really bizarre and like really like counterintuitive, but it's true. And if you think about it, it is actually intuitive because like because life itself is just filled with so many novel phenomenon that it's hard to show that all of that is a consequence of just very fundamental laws. Like those fundamental laws need to be broken in order for new things to emerge. And this is evidence for that. Furthermore, time-dependent potentials enable downward causation, as in the case of digital computers. Downward causation is the principle that higher emergent phenomenon can have an influence on the substructures that compose them or that gave rise to them. So again, in the free will example, it means that my consciousness can influence matter. And it can. Like I can right now. Like right now, I'm moving my hand in a very arbitrary and random way, showing that my consciousness is able to move matter and cause matter to do things which it doesn't ordinarily do, and which you wouldn't expect it to do given the laws of physics. If you wanted to predict what my hand is going to do, the laws of physics are insufficient. You also need the laws of consciousness. You need to add consciousness into that picture, and then you might be able to predict it. But of course, consciousness by its nature seems to be something that's unpredictable, especially if it is of itself strongly emergent. Additionally, I show that the processes of evolutionary emergence of living systems is also a case of strong emergence, as is the emergence of properties of life. So this is another separate proof that evolution is emergent. Evolutionary emergence of living systems is also a case of strong emergence. This should really just like underlie the fact that strongly emergent phenomena can be completely different from each other. Like the process of evolution seems like this very, time dependent, very like almost like abstract kind of thing that's happening, and yet it's strongly emergent. And then you take like semiconductors and the properties of semiconductors, and clearly that has nothing to do with evolution, but it is strongly emergent given in a kind of like different direction. So like things can move in their own directions and become strongly emergent with respect to the systems from which they arise. So very fascinating and very complicated. So again, if you're confused, you should be, because this is confusing. This is confusing and all-encompassing. As is the emergence of properties of life out of the underlying physics. A useful result emerges. Standard physics theories and the emergent theories arising out of them are all effective theories that are equally valid. Now, this is a very important thing, which I need to refer to constantly, which is also important just for understanding emergence in general. But it's kind of hard to explain, and I have explained it already in this stream. But just briefly, what this basically means is that once an emergent property comes into existence, so like evolution, you can create equations that describe evolution. And those equations are valid for evolution. And it's not like, well, no, those theories are not actually true. It's really the physical theories that are true, and then this theory is just kind of like an abstraction. No, the theories, the math that governs evolution is a genuine math which will predict evolution for you. So you can create a new theory at a higher level, and that theory is perfectly valid. It's not invalidated by more fundamental theories. So that's kind of what's the main point that's being here. Okay, so this is my cue to leave because I can see that Dilip is saying I don't believe in free will and that we were predetermined to be together. I'm going to continue this discussion after dinner, just so I have some more energy to get through this paper, because holy shit, just look how much there is. And these equations, I've gone through them; they're valid. I mean, obviously they're valid because they've been published in a paper. But I've gone through them and I've seen how it is that these can these equations here can actually give rise to strong emergence. So again, it's fully backed up by math. And mathematical principles. But yeah, there's a whole bunch. This is the Hamiltonian for electrons, I think. And then he shows
there's this thing called the Bohr-Oppenheimer approximation, which actually is strongly emergent. So like even like at the level of fundamental particles, there are strongly emergent phenomenon. Another example would be like the quantum Hall effect, which I think he mentions. That's an example of a strongly emergent phenomenon. And not everything that happens at the level of particle physics is strongly emergent, but the fact that there are any strongly emergent phenomenon is a good indication that things like consciousness are strongly emergent, especially if consciousness depends on those strongly emergent properties. That in and of itself is strong enough proof that consciousness is strongly emergent. Yeah, this paper goes on for a while. Okay, so I'm going to come back and look at this. It's so cool. It's so cool, this paper. And then I'm going to look at another paper, which is specifically about free will, temporal asymmetry, and computational undecidability, showing that there's a connection between undecidability and free will. And there's a connection between undecidability and emergence as well. And that'll be fun to describe. What else do we have? Go through this paper. And then we have one that shows why undecidability is very important for evolution in the context of artificial intelligence. Very cool. We'll go through that. And then I think the last one is, this one is really cool. It shows an example of strong emergence in Conway's Game of Life. So if you're familiar with Conway's Game of Life, there are weakly emergent phenomenon within Conway's Game of Life. And then there are strongly emergent phenomenon. And what this guy shows is that those strongly emergent phenomenon arise out of weak emergence. So weak emergence occurs first, and then several weakly emergent phenomenon can give rise to a strongly emergent phenomenon. Very cool. And again, you can prove that it's strongly emergent. So yeah, I'm going to take a break. Thank you all for watching. I'll be back later, so if you guys are around then, feel free to tune in, and we'll continue discussing this, and hopefully you enjoy it. Yeah, take care, and thanks for watching.